In this video, let's take a look how can we copy these boxes that we create to the points that we create from our curves, and also how can we outsource our box on top of the HDA. First of all, let's go inside our HDA. So this is the HDA that we left from the previous video. So let's go back and go inside type properties, and here in basic we can select the minimum and maximum outputs. So what we want to know, we want is actually two inputs in our node. So just the maximum input, so we want input, so apply, and here we go. So basically now it's gonna give us option for two inputs, and if you go inside this one, you can see it's kind of created these two nodes that are basically whenever we're gonna select into one or two. So one, the first circle is going to be our one. So you want to outsource our box, you can delete this one and put inside subnet input one, and then just create the box outside and put it here, and you can see it's basically the same thing. So we have outsourced outside our HDA this box. The minimum input is basically going to give us errors if we do not have two inputs inside our HDA. So if you do not have anything selected inside these, it's going to give us error and it's not going to work. So for that, I'm going to just put 0 and maximum 2. And that's it for now. So let's put in this box and let's create a curve. So for me, let's take a look. Let's maybe something like this. These are the points that we want to copy our boxes to. Now let's connect our curve to the HDA and let's go inside this. First of all, since you want to change the place of our boxes in translate, we can just delete all these channels that we created that reference outer these channels. So just delete them. So down now it's all going to be at 0. And all we really have to do is first of all create that our iteration amount is same amount as our points that we have on our curve. So we know that our curve right now has, let's take how many points we have. So go to the points, take a look. So now we have 8 points. So now we have to always make sure that our out of HDA, that our HDA has boxes always 8 when that follows our curve amount. All we have to do is write down an endpoint function. So let's put down endpoint. So what the endpoint function does is basically gonna give us an integer value of how many points we have at this point at geometry that we want to point at. If you know that we want to point at my curve, so all we have to do is just start writing in quotes my curve, and you can see it's automatically gonna give us, and that's it. So basically now we have set up our link between our box's amount and our my curve that is referenced outside of the HDA. And since we can change this curve to whatever we want, and it's always going to be referenced as my curve, so that's why we give this kind of reference inside our HDA. So whatever our curve is named, it's always going to be referenced as my curve later on. So that's one trick we can do. And now all we have to do inside our HDA is have to go to transforms and use a point function to reference the positions of our curve points. So let's just write it down. So use point, and now we'll have to reference our my curve dot slash my curve. After that, we want to use a detail function. Remember, detail is basically going to get us. So instead of static, get the point, whatever point we want from our curve, we want it be dynamic for every loop. So that's why we are referencing this iterator. So we know that iterator is dynamic for every loop. It's going to increase from 0 to 1, 2, 3 and all that, and how many points we have in this curve. So that's why we are using detail instead of just a simple number. Detail, then we want to metadata. After that we have to detail attribute, which is iteration, and after that 0. So now you can see this is our basically point number, which is just a one pocket of our point function. So still is in, if you go into help, you can see it's as for the points we have. So this is our point number with the detail. Now we have to say attribute, and after the brackets we have the attributes. We know that it's a p, and after that we have to say which if it's a vector, since it's a vector, we have to specify which pocket of the vector. So for the x is going to be 0, and that's it. If you change it, you can see it's 14.01. If you take a look at my curve, very last point is 14.01. So that's, we know that works, and all we have to do is copy it, paste it, and change it the last one. So that's x, y, and now I want to z. That's going to be 2, and that's it. You can see we are now basically copying every box to the point location. Let's go outside, go inside this curve. Let's rewrite it, and you can see every box is following to the curve, and of course, because we set it up in HDA, we can, every box can be changed individually, the color of it, and whatever parameters we want to give it here. Since we are now using since we are no longer using translate, let's convert this translate to the rotation. So for us, transform this, let's individually rotate these boxes. So what we can do is just, let's call it rot apply. Now all we have to do is reference this channel. So for that we can go to the color, and we know that we created these color channels. Let's just copy it. Let's go to transform, and for rotate, let's just paste it inside. All we have to do is, so we have to change the reference to rotate. So for detail it's the same thing, and for the translate it's x, y, and z. Let's say x in here, y, and z, like that, and that should be it. Let's go back to the on top of it. Let's try to translate it. You can see now we can, we can individually rotate these boxes. What's great about this setup that we can, without going inside our HDA and messing around with networks, you can just plug in whatever we want and then change it on the fly. So this is completely different geometry. You can see you can very specifically translate whenever you want, color of it, and whatever parameters you want to change again. So that's it for this tutorial. I hope you've seen. See you next time, and take care.